Happy Monday, Cristo Rey Saints. This is Mr. Lovelace recording your weekly overview video for pre-calculus. This will be the same video for all of my pre-calculus classes. So if you are in the junior or senior sections, what you're going to want to do to know your schedule for this week is to go to Google Classroom. You're going to find the updated, reposted 2-week calendar, which was really a week and a half leading up to the spring break. So please look over that carefully today so that you know what's coming up. Juniors, you should note that your Zoom class is tomorrow, Tuesday, rather than the end of the week. So that will be this week and next. Seniors, your Zoom class this week will be on Thursday as usual. All assignments have been posted in Google Classroom, including reminders regarding the Khan Academy video deadline, videos and exercise deadlines if they have some. This week, I think you guys just have videos to watch. There's also a link in your Google Classroom to another website for more practice with what we're going to be doing this week. But the focus will be on the book this week and problems out of the book. So I will be assigning later in the week, or we'll be discussing later in the week when we meet. So juniors tomorrow, seniors on Thursday, what I want you to actually hand in this week in regards to homework, since there aren't any Khan Academy exercises that will be counted as a homework grade this time. And then also, since it's a short week and a half, your assessment for this week will actually not be due until Wednesday next week, which is the last day we meet before spring break. So a little extended time this week in regards to the assessment itself, which will be posted by the end of the week, probably on Saturday or Sunday, so that you have a little time over the weekend to work on it as well. But you should have plenty of time leading up to that Wednesday deadline for your assessment to be complete for this week. So let's talk about the topic for the week. The topic for the week is inequalities. So we haven't probably talked about inequalities in a while. Mostly we've been talking about how to solve equations. So what you're going to want to do is have your book open to page 359. So page 359 is chapter 2 in section 7. So polynomial and rational inequalities. So we just finished talking about rational functions. The focus for this week and next will be on polynomial inequalities. When we come back from spring break, we'll pick up with rational inequalities. So all the work we just did on rational functions will come back when we come back to that section, to this section after spring break. So today, just a quick overview of what a polynomial inequality is and how we would solve it. So flashback to algebra. Okay, polynomials, which we saw in rational functions. Rational functions are composed of two polynomials put into a fraction or a ratio. So a polynomial function is all those functions that fit a certain form, and we've seen lots of them, right? When you started algebra for the very first time back in Algebra 1, you saw linear functions. They called them linear equations at the time. Okay, that's an example of a polynomial. So is a quadratic, so is a cubic. Basically, any function that is formed by combining together a variable in sums and differences, so adding and subtracting with powers. So this first example actually in the book on page 359 is an example, an application using a quadratic polynomial. We know it's quadratic because of the power of 2 being the highest power or the degree of this polynomial. Okay, so quadratic functions you spent a lot of time in on Algebra 2. So this should be familiar, at least in terms of the type of function that we're looking at. And that's what we're going to illustrate today using a quadratic function. Okay, so why is it called an inequality? Well, because it's not an equation. That's pretty much it, right? It's not an equal sign here, it's an inequality symbol. And there are 4 inequality symbols, right? And reading them from left to right, we have less than, greater than, less than or equal to, greater than or equal to. Okay, so a polynomial inequality is any inequality that fits one of these forms where the function f is a polynomial function. We can create any type of inequality with a function, but we're going to use polynomials to illustrate because those are things that we've seen a lot of and they're fairly easy to understand. Okay, so I'll let you refer back to the book. I'm going to go through a problem using a familiar function, a type of function, which is a quadratic. Adjust my camera here a little bit. Okay, so we have this function y equals x squared minus 8x plus 12. We know that's a function in x. We say y is a function in x, and you could just as easily write it. Just as easily write it in this way, right? Function it just tells us that we have an input, which is our x variable values, and an output, which when we're graphing it, we refer to, of course, as y. Okay, so if I ask you to solve an equation of this type, right, what does that word solve mean? Okay, so solve means to find the values of the variable. Maybe there's only one. So I'm going to write value with s in parentheses. It could be one value, it could be more than one. Find the values of x that make the statement true. Okay, an equation is a mathematical statement, right? Y equals x squared minus 8x plus 12. Is that always true? Well, surely not always true, right? I could pick an x and y pair of numbers that don't work for this equation, right? But if I find the values of x that make the statement true, in this case, it's going to be not just x, right? It's going to be pairs of values of x and y. Sometimes it's an ordered pair set, right? What are all the pairs of numbers x and y that make this equal, that make this true? And that would be, for example, the graph of a parabola is the set of all the ordered pairs x and y that make this equation true. Okay, well, if I pick a specific value of y, then what I'm asking for is what are the values of x specifically that make this statement true? So our usual equation we solve is this one. 0 equals x squared minus 8x plus 12. So I'm picking a value y. I'm picking the value y equals 0. And I want to know what values of x make this equation true. Well, not every value of x makes this equation true. 0 does not make this equation true. If I let x equal 0, I get 0 minus 0 plus 12, which would say that 0 equals 12. That's not true, right? So 0, x equals 0, is not a solution to this equation because x equals 0 does not make this equation true. So this equation right here is a quadratic equation, and you've learned several methods to solve this, including factoring, which we've practiced a lot in the last week. So first thing we would try would be to factor this expression, and right, we would find this factoring works, x minus 6 times x minus 2. So we factor the equation, factor the expression, we get two factors that are multiplied to equal 0, and then our method when we're factoring to solve an equation is to set each factor equal to 0 and solve for x. Okay, so we have found two solutions, x equals 6 and x equals 2. Both make this equation true. And we know those are the only values of x that make this equation true. Okay, so that's this method of solving an equation for a specific value y. We're looking for values of x that make the equation equal 0, make the expression here equal 0, which would make the equation true. Okay, two solutions. Okay, solve the inequality. It's the same exact question. What are the values of x that make this inequality true? So not every value of x is going to make this inequality true. X equals 0 would not make this inequality true. If I put a 0 here and a 0 here, I get 0 is greater than 12. That is not true, right? So x equals 0 cannot solve this inequality. But there are many values of x that can solve this inequality. And how do we find them? All right, so if you look in your book, there's a process of how to do this. Okay, so I'm going to jump down to the bottom of my page of notes real quick. And if you want to see how the book presents it, you can look on page 360. But let's boil it down into the essential things. Number one, we're going to solve the equation first. And we're going to solve a specific equation, f of x equals 0. Okay, so whatever the function is, whatever the expression is, I'm going to first get everything to one side and have a 0, and then I'm going to solve the equation f of x equals 0. Okay, so what this does is it finds what the book calls boundary points. Okay, and that'll become clearer when we finish the problem. Okay, so first thing we do is solve the equation f of x equals 0, find the boundary points. So in this example, right, it's the same exact thing except for the inequality symbol. So I've already found the boundary points. The boundary points are x equals 2 and x equals 6. Okay, so at those values of x, the equation is actually equal to 0. Okay, but that's not what I want to do, right? I don't want to find the values of x where the equation equals 0, where the expression equals 0. I want to know where they're less than 0. Okay, so what I'm going to do next, is I'm going to create intervals of x and choose test points. Test points. Okay, test points. So there's two kinds of things. There's boundary points and there are test points. The boundary points are the values of x that actually make the equation equal 0. Okay, the test points are going to come from the intervals I create using the boundary points. So creating the intervals of x starts with the domain, right? So we've talked about domain a lot. The domain of this expression, x squared minus 8x plus 12, that's a quadratic. So polynomials, all polynomials, the domain is all real numbers. So we're going to create intervals of this expression using the boundary points. So the boundary points create intervals. I have 2 boundary points. I'm going to have 3 intervals. Okay, my first interval is going to start from minus infinity and go all the way up to 2. Why? Because in this section, for this expression, I can pick any number in this interval from minus infinity up to 2. And I can also pick any number between 2 and 6. And I can pick any number between 6 and infinity. Okay, so I'm just looking at all the possible values of x I can choose for this function, for this expression, because I want to know what's going on in this interval, what's going on in this interval, what's going on in this interval. And I know at the 2 and at the 6, this function is equal to 0. I want to know where is it less than 0. So I'm really looking for this interval, and this interval, what's happening in these 3 sections of the function. Okay, so I'm going to choose test points. So I'm going to choose easy test points, as easy as possible, right? So let's say I'm going to pick 1. You know what? What's even easier than 1? 0. Okay, 0 is in that interval, so let's pick it. Let's use it. So these are my test points. Okay, here I'm going to use 3. And here I'm going to use 7. Okay, it doesn't matter what you pick, as long as it's inside the interval. If you have the option to choose an easy number, pick the easy number. Okay, then what am I looking for? Well, what am I looking for? I'm looking for any value of x where the value of the expression is less than 0. All right, this number is less than 0, or 0 is greater than this number. So all I really want to know is this number positive or is this number negative? Okay, if this number, when I put an x value in, is positive, okay, then that is not going to solve my equation or my inequality, because a positive number is never less than 0, or 0 is never greater than a positive number. So what I'm looking for is what values of x make this expression actually less than 0 or negative. Okay, so I'm going to take the test point and I'm going to put it back in here. But since I've already factored it to solve the equation, I might as well use this if it factors. And all I'm looking for is it positive or is it negative? Okay, so I'm going to put the sign, okay, positive or negative in the interval. So put a 0 in here. You get 0 minus 6 times 0 minus 2. So let me just write that under here. Okay, and this is a negative times a negative, which makes a positive. Okay, so we're going to do that for each interval. So over here, we're going to do 3 minus 6 times 3 minus 2. And here we're going to do 7 minus 6 times 7 minus 2. 3 minus 6 is negative, 3 minus 2 is positive. So when I multiply those, I'm going to get a negative number. I don't care what the number is at this point. I just want to know, is it positive or is it negative? And then over here, 7 minus 6 is 1, that's positive. 7 minus 2 is 5, that's also positive. When I multiply them, I get positive. So because of the nature of polynomial functions, any number I pick in this interval is going to give me a positive value for the function. Any number I pick in here is going to give me a negative number for the function. And any number I pick in this interval is going to give me a positive value. So of all 3 intervals, the only one where the function value, meaning this part, is negative is going to be between 2 and 6. Okay, so what that tells me is my solution is x is in the interval from 2 to 6. Okay, remember how we do intervals, smallest number to biggest number. Parentheses indicate that the endpoints are not included, okay? Now, could they be included? Yes, and the only thing that would change, it would be or equal to, right? If I put an or equal to here, then I'm not only looking for when these values are negative, but I'm also including when they're equal to 0. But I've already found those. They're right here, okay? So that's the 2 and the 6, and I could just change that to brackets instead of parentheses if this was a or equal to symbol, okay, which is certainly possible. All right, so here's my solution. X is between 2 and 6, okay, and then the last thing you'll see in the book is, right, a little sketch. Okay, once I find my solution set, right, I'm just really talking about 2, 3, 4, 5, 6. I'm really just talking about this interval, and go back to number line graphs, right? We put an open circle on the endpoints in this case, and we just sketch everything in between. So any value of x in this interval from 2 to 6, if I go back to my original problem, is going to create a value on this right-hand side, which is going to be less than 0, and that solves the inequality. Because remember what solving is? Finding the values of x that make the statement true. So any value of x between 2 and 6 will make this statement true. Okay, so there's the picture again of what we do. We divide up, we find our boundary points by setting it equal to 0 and solving for x by factoring in this case. We create the intervals starting at negative infinity and going to positive infinity. That'll be the case for all these problems because they're polynomials. They always can go from minus infinity to plus infinity in the domains. Choose test points. Set up what that product looks like if we're able to factor it. If we're not able to factor it, then we just have to find, well, what's the function value? But we're really interested in this. We're interested in the sign of the answer. And for our particular problem here, we're looking for values where the function is the x squared minus 8x plus 12 is less than 0. And I apologize, I think I wrote this wrong here, didn't I? Sorry, it should be this way. Hopefully you caught that. Okay, and so this is the section, this is the part I'm looking at. That's the interval for which all the values of x make this value equal to a number less than 0. Okay, so back to our steps real quick. Solve the equation to find the boundary points, create the intervals, choose the test points, and then check the value of f of x in each interval. And really by value, what I mean here is the sign. Is it positive? Is it negative? Okay. All right, so there's an illustration. Real quickly, just to let you see what's happening visually. I'm going to go, share my screen real quick. If you go to Desmos, right, you can graph this function y equals x squared minus 8x plus 12. And you're going to get a parabola. And you're going to find that the intercept values are 2 and 6 because that's where the function equals 0. So where is this function? Remember, function is the y values. Where are the y values negative? Well, here's where they're 0. Here's where the function values are negative because that's where the y values are negative. And where does that happen for the x inputs? Between 2 and 6. So if I choose any value of x in this little section here, between 2 and 6, where's the y value? It's down here. It's below the below the x-axis. So these are all negative y values. If I pick any value of x less than 2, so anywhere along the x-axis less than 2, where's the function value? It's up here. The function value, the y value is positive. And then the same on the other side, 6 or larger, larger than 6, right? My function, the y values are up here, they're positive. Okay, so this is the picture of the quadratic function that goes with the solution that we just found. Okay, and the solution we just found was any value of x between 2 and 6 is going to give us, right, a function value less than 0. Okay. Okay, so you're going to see examples of that in the book. You're going to see examples of that on the Khan Academy videos. Go ahead and post your questions in the parking lot or send me an email. We will have office hours as posted in your schedule. So go ahead and don't forget to check your schedule often. Go back to that and then send me questions that you have about anything I've talked about today. Juniors, I will see you tomorrow in class, and seniors, I'll see you on Thursday. Okay, take care, everyone. Have a great day.